Welcome, video example 3, unit 3, chemistry 1B. Okay, so we want to calculate delta G for the following reaction. Now, we've got a reaction that is given here, and we are given an E cell value. Okay, so to solve for this, we assume standard conditions. So the temperature is 298 Kelvin, and then we use the equation delta G standard is equal to minus N and then the F E standard, okay, where N is the number of moles, F is the Faraday constant, and the E standard is the E cell, okay. So here you can see that for this reaction, if you look carefully, gold 3 goes to gold. 3 plus was its oxidation state to 0, implies 3 electrons. And similarly for aluminium. Aluminium loses 3 electrons. Okay, so that means that N is equal to 3. This is the Faraday constant. Remember, this is 96,485. The Americans have a strange way of separating thousands with a comma. Okay, and then we have the E cell over here. All right, so that's the E cell. So you can see that the number of moles of electrons cancel here. And remember that the volt, okay, we have to convert to joules. The volt is 1 joule per coulomb, volts, okay. So you can see that the coulombs cancel over here and the volts cancel over here, such that when we finally solve the problem, we see that we get a very large value in joule per mole, because remember this is joule, there's the joule per mole. Okay, so it's 914,678, and if we convert to kilojoules and do the rounding and the significant figures, we end up with negative 915 kilojoules per mole.